Hi guys, want to give you some little bit of the information that we didn't have time to talk about in class as you were getting registered. So hopefully if you get through this video as quickly as possible, then you don't need to do so many of the help me solve this or view an example pieces if you just kind of pay attention a little bit, okay? So a linear equation in one variable is an equation that can be written in this form. Ax plus b equals c, where a, b, and c are real numbers. Okay, so another thing that I want you to keep in mind is that a linear equation, right? No exponent on the variable other than 1, and it would have no variables in the denominator of a fraction, and you would also have no variables under a radical. And it would also have no variables with an exponent. So I'm not even going to write that again, really, because you should not have any variables with negative exponents. So let's talk about examples of linear equations. Notice in this particular case that the variables on the side, it has an exponent of 1. The variables on the side of the radical, it has an exponent of 1. The variables on the side, and even though this is being squared, the x is not. Notice that these are linear terms as well. So those are all examples of linear equations. So nonlinear, notice this is a variable in the denominator of a fraction, and this is a variable under a radical, and this is a higher order. This is also a higher order, higher power, okay? And this is negative exponent. Can't have a negative exponent also. Those are non-linear. So notice that those are non-linear, okay? So let's just solve a couple of equations. I don't think it's a big deal. Hopefully you're going to find some problems within that homework assignment that are pretty easy for you to solve. You're going to distribute the 4, right? And you're going to get 8x plus 20 equals 10 minus 2x plus 10. Don't forget to distribute the negative with the 2, please, okay? And then I'm going to just combine like terms on the right because there's a couple to do there. So I have negative 2x. And then remember that this was a 10 right here. So 10 and 10 is plus 20. I'm going to add the 2x to this side. And I'm going to subtract the 20 to move it to the other side. And when we do that, we're going to get 10x equals 0. Then you can divide both sides by 10, divide by 10, and you end up with x equals 0. 0 is a legitimate number. It's not a no solution problem. So hang tight to that. Be careful about that. Okay, the next one we're going to solve looks a little bit different and has fractions. The very first thing that I'm going to do actually is just distribute this fraction. I'm going to go ahead and distribute this fraction to the two terms right here so that you can see what's going to happen. This would look like 2p over 8 minus 1/8 equals 7/3 p minus p minus 4 over 6, okay? And then what's going to happen is I'm going to multiply by the LCD. So the LCD is the smallest number that all of these denominators 8 and 3 and 6 go evenly into. And if you don't know what that is, it happens to be, it can't be 12 because 8 doesn't go evenly into 12, so it must be 24. So I'm going to multiply every single term by 24 and cancel what I can cancel, okay? So here's what that looks like. After I cancel this, I'm going to end up with 3 times 2p, right? Minus, and then it's going to cancel here and give me 3 equals 3 cancels with 24, and I'll end up with 8 times 7p. 6 cancels and divides into 24 4 times, and I'm going to end up with minus 4 times p minus 4, okay? And then if we keep going, we're going to get 6p minus 3 equals 56p minus 4p plus 16. I'm going to combine these like terms and get 52p plus 16. 6p minus 3. And then I'm going to do this. Just because I like to try to keep the coefficient of the variable positive, I'm going to subtract 6p, I'm going to subtract 6p, and then I'm going to subtract 16 and subtract 16. Okay? When I do that, I'm going to get negative 19 equals 46p. Now I'm going to divide both sides by 46 to isolate the variable, and I'm going to get p equals negative 19 over 46. And I know some of you don't like numbers like that, but those are perfectly legitimate. Please make sure you pay attention to the directions in my math lab because you probably would have to type that in as a fraction. Be careful that the directions are underneath the box where you're going to type in the answer, and that kind of always throws things off a little bit. Let's see if I missed a page right there. Okay, so let's solve a linear equation involving decimals. There's a couple of these in your homework, so I'm going to go ahead and distribute. Again, that's the first thing I'm going to do. 0.002 minus 0.002k plus, and I'm going to have to distribute 0.01 plus 0.01k minus 0.03 equals 1. If you'd like to clear out your decimals, you certainly can, but you're certainly allowed to use your calculator if you want to. So what I'm going to do next is I'm going to combine these two like terms right here. So I've got negative 0.002 plus 0.01, and this is going to be that's going to make this 0.008k. If you think I've made a mistake here, please make sure you catch me. And then the other, I'm sorry, that's a positive 0.08k, 0.008k. And then the next thing I'm going to do is I'm going to combine these other terms right here, 0.002 minus, so 0.002 minus 0.03, and I'm going to get negative 0.028, and that was a positive, equals 1. Now I'm going to add that, so I'm going to do plus 0.028 to move that to the other side, plus 0.028. Okay. So now I have 0.008k equals 1.028. And now what I'm going to do is divide by 0.008, divide by 0.008. If you feel comfortable with eliminating your fractions first, your decimals first, then certainly by all means feel free to go ahead and do that. I'm going to cancel these, and then 1.028 divided by 0.008 is going to give you 128. Okay, is equal to 128.5. Again, pay attention to the directions about how you need to type that in. Okay? All right, a rational equation. His equation consists of a rational expression with variables in the denominator. Okay, one or more rational expressions and any other expressions being polynomials, but really what you want to look for is has variables in the denominator. Okay, has variables in the denominator. Got it? All right. So these are some examples of rational equations. Notice right here that x is in the denominator, x squared minus 1 is in the denominator, 8x is in the denominator. That's what makes all of those rational equations. Here's why these are not rational equations. This is in the numerator right here. If it's off on the side, then it's in the numerator. Okay. This is not a rational equation because it's a root. This is a radical equation. Radical equation. Okay. And this one is not rational because you have no variables in the denominator. Okay. And we do want to look for polynomial expressions, rational expressions with any other expressions of the equation being polynomial rational expressions. Okay. All right. So you'll have to identify a few of those. And then to solve rational equations, you're going to follow these steps. You're going to factor any denominator, figure out what the LCD is, multiply through by the LCD, and then solve the result. One of the best things that you can do is, like, if you want to check to see if x squared minus 6x plus 8 is the LCD, how about if you take x minus 4 over here times x minus 2 over here and just FOIL it, right? And then if you FOIL it, x squared minus 2x minus 4x, and then plus 8 is going to give you x squared minus 6x plus 8, which actually is that denominator. So that is the LCD. So what we're going to do is we're going to multiply through by the LCD, but the factors of that denominator are x minus 4 times x minus 2. So we're going to try to cancel everything we can cancel. So I'm going to put parentheses around this and this and this, right? And when I multiply through by x minus 4 times x minus 2 to each of these, that means it goes to this term, and it also goes to this term, and then it also goes to this term. Then what's going to happen is anything that's part of that LCD that's there in the numerator is going to cancel with its common factor in the denominator. So for the first one, this x minus 4 is going to cancel, and what I'm going to be left with is 1 times x minus 2. But when I multiply it to the next term, 2 over x minus 2, the x minus 2 is now going to cancel. I'm going to be left with 2 times x minus 4. And then when I distribute it to the term on the other side of the equal sign, they will both cancel, and I'm just going to be left with 2. Got it? So try to cancel out those denominators to make an easier equation to solve. So you get x minus 2 plus 2x minus 8 equals 2. Combine like terms, 3x minus 10 equals 2. Move the 10 to the other side, add 10 to both sides, and you get 3x equals 12. Divide both sides by 12, you get x equals 4. Right? Okay, but watch out. Notice that you need to check for extraneous solutions. Watch out. Remember that an extraneous solution is a solution that does not solve the original equation. So we got x equals 4. But in the original equation, remember that we had x minus 4 up here in the denominator. I'm going to see if I can highlight this for you. We had x minus 4 in this denominator, and so what happens is when I substitute 4 in for x, I'm going to get a 0 in the denominator. You cannot divide by 0, right? So you're going to exclude it. Let me see if we can go back to just the pen tool. You cannot divide by 0. So we're going to exclude it, and your solution is actually no solution. And I think that no solution is probably going to be an option for you there, okay? Good. That's good enough. Let's try something else, a little bit different. Is that the last thing we had? Possibly. Yep. Okay. That's it for section 1.1. I want you to make sure that you email or text me something. Let me know if you have any questions about that particular section. If you have questions about solving rational equations that you didn't get answered, then make sure you check with me.